In Mark Twain's A Connecticut Yankee in King Arthur's Court, a man from the 19th century is able to take over a medieval kingdom with his knowledge of the science and technology of his own day and quickly builds factories, telephones, and firearms. This trope has been repeated over and over in popular culture. But is such a thing possible? This activity will take place in two parts. First, your professor will set up a Jamboard or discussion forum. Form teams with your classmates. Each team will choose one modern invention that would have been useful in the Middle Ages, say, automobiles, firearms, or telegraphs, and discuss what is needed to make it, both in terms of materials and in terms of construction techniques. HowStuffWorks.com can be a good resource for this. For instance, a modern firearm not only requires nitrocellulose powder and quality-controlled steel, but it must be carefully and precisely machined or it will explode. The same with an internal combustion engine, which is essentially a series of small bombs going off many times per second. A telegraph, meanwhile, not only requires a lot of wire and insulator, but a constant source of electrical power. Even if you know how to make one of these devices, it would be difficult to do without modern machine tools such as drills, lathes, and presses, or to power them without modern engines. You will quickly realize that all modern inventions are contingent. That is, they build on what people have done before. For instance, without Henry Bessemer's invention of a new smelting process in the 1850s, we would not have inexpensive steel. However, Bessemer was only able to make his process work because of decades of work in metallurgy. Now, let's consider how medieval people actually performed impressive feats of engineering, such as making cathedrals. One of the first requirements of modern manufacturing is precise measurement. However, precise weights and measures, accurate to fractions of a second, centimeter, or milligram, were not possible in the Middle Ages, and standards were different from place to place. Therefore, instead of measuring absolutely, as we do with a stopwatch or meter stick, medieval people measured proportionately, measuring one thing against another. For instance, cathedral bays are proportionate to the whole. Medieval people defined a day not by referring to an artificial device such as a clock, but as a complete revolution of the stars in the sky. Similarly, researcher Peter Johnsson discovered that medieval swords are based on a series of circles. By using these proportions, medieval swordsmiths were able to predict the physical properties of the finished product, creating a weapon that, far from the cumbersome bludgeoning weapon portrayed by Mark Twain, would be both agile and transmit the maximum force to the target. In keeping with the medieval worldview, these proportions were given metaphorical meaning. To learn how this worked, let's use Google Draw to use proportional measurement and geometry to plan out a cathedral, following Professor Jennifer Feltman's lesson plan. To begin, open Google Draw and create a 5x5 square. Make sure it's transparent. Now, divide the square into 4 at the midpoints of the sides, and then draw a diagonal from the middle of the bottom to the top right. You'll want to make these dotted or dashed lines. That diagonal is very important. It's going to form the radius of a circle you're going to use to make arcs to find the golden proportion. Once you've made the circle, making sure that the radius is equal to the diagonal, you can make an arc using the arc drawing tool that's equivalent to one side of the circle. Copy that arc, and using the orientation tool, arrange your arcs so that they intersect at the midpoints of the squares. Now, use the line tool to create the great square, a larger square outside of the first one. Make a diagonal in the great square and use that as the radius for a circle that will give you the length of the nave, the main corridor of the cathedral. Do the same for the other side. Now copy the circles you made from the great square. These will give you the length of the transept, that is, the crossing corridor. Now look where the arcs intercept the great square. The line is divided according to the golden ratio of 1 to 1.618, which we perceive as harmonious, and which occurs many times in nature. This line is the length of the apse, the back part of the cathedral, where the priest performs Mass and there are smaller chapels for worshippers. By the way, if you run out of room, you can zoom out, make your canvas bigger by pulling on it, select all, and reposition your plan. Now you can make an inner circle for the apse, but the back of the cathedral often has a double aisle, so add another golden ratio and draw the apse itself. And there you have it. If you look at some cathedral floor plans, like this one of Chartres Cathedral in France, you'll find the proportions match closely. In this exercise, we discussed how inventions are contingent, or rely on previous developments. We discussed how one of these important developments was precise weights and measures, and how, lacking these, medieval people had clever means of measuring proportionately. We then did an exercise in using proportional measurement to draw a cathedral floor plan. As an additional activity, you can research and think about things such as gear ratios and ways of transferring energy from one place to another. For instance, look at the classical 6 simple machines. How would you use these techniques to construct such a device using the materials and methods available to you in the Middle Ages? If you have the software available, you may wish to model your device.